Whoever's watching this, you on my side. Alright, man, let's not do this. Oh, I didn't do that. Justin. Bro, I dropped my fucking mouse. Did he send this shit out? Where did he send it? Bro. Bro.
Can you see the whole thing now?
Yeah.
Yes.
Yo, you actually fixed it, bro.
Ethan, can you see it clearly?
Yes, bro. Yo, I did not know where you put the link, bro. I spent like 5 minutes trying to find it. I was checking my email.
Alright, let's see. So if it works on this, this is literally with the webcam. So that means I should get rid of the phone.
It's low-key blurry, I can't lie.
Let me see. So microphone's working, paper's working. Oh man, that means you can't see the board now. You can't see the joke. Is it blurry again? Let me try again with the phone. Welcome everyone. I'm just trying to get this camera thing to work. Hang in there, we'll get started. All right, let me see. All right, guys. All right, guys. Can you hear me? All right, we're going to get started. We're having some problems with the camera quality a bit. So at any point today, if the video is blurry, please unmute the microphone and yell at me, and I'll try and fix it.
Is it good?
Oh, wait, let me see. Let me just see if the camera is technical difficulties. That's still blurry. I'll just use the webcam. All right, so first off, I want to apologize for last class in the sense that my camera was not on center. When I looked back at the video after the class, I realized the camera was not centered, so you couldn't see the full problem the entire time. So yeah, if you can't see what I'm writing at any point, please just yell at me and I will fix it, okay? Because there's not much point in me doing the math out if you guys can't see it. All right, so couple of quick announcements. The homeworks. Please make sure we're doing the problems that I assign after class, because in my section of the class, every single class builds on the class before it. So I'm getting a good number of submissions for the homework, people uploading their pictures of the problems. Please keep on doing that. So once you finish the homework, upload a picture so I can get a quick temperature gauge as to how people are keeping up and if they're understanding the material. If I see that people are getting a lot wrong on the pictures, I'll try to slow the class down a bit. Other than that, remember that the homework, do the homework, or else I put you on the list. And you don't want to go on that list.
Justin, what's the list?
And I'm not saying the first day, it's the Santa Claus list. The list I send to Santa Claus at the end of the year. And if you don't do the homework,
bro.
go on the naughty list.
You were saying something else earlier.
All right. Now that we got that out of the way, hopefully we were able to read the joke of today. All right, let me move the camera real quick. Great, awkward transition, and it's gonna go. All right, can we see it clearly? We can read it. If at any point it becomes blurry, please let me know. Oh, great, now I can't walk in here. All right, so. Actually, let me move the whole thing. This is not handicap accessible. All right, so we're going to start with going over the homework quick. And Ethan, make sure you record this so that someone's not here.
It's recording, bro.
Okay, thank you. All right, so we're going to go over the homework, but first off, I want to start with a quick little detour. A lot of us in this class are rising juniors, so a lot of us have been asking me how to prep for the SATs, since I know that's probably what we're doing this summer. I posted an announcement about the SAT, how I study for it, but I just want to give a quick mention on what I use to study. This is the actual book that I use. This is Crash Course for the SAT. It's a very thin book. You can see it's very short. It's not too long. It gives you just enough information to do well on the SAT. So if you want to know how I studied, I posted the announcement a couple days ago, and it's worth a quick checkout if you need some study tips. Any questions so far? No? All right, feel free to unmute if you ever have a question. Other than that, we're going to get started with a quick homework problem to review what we did last time, because today's material builds on yesterday's or last class's material. And if at any point I make a mistake, because I do make mistakes, please feel free to yell at me so I can fix it. Okay, so we have this problem from last time. It's on one of our homework packets. I believe it was maybe the third to last problem. Do you see it on our homework? It says we start with 16 grams of MgCl2. How many grams of NaCl do we have? So what we start by doing is, remember, when we're given a stoichiometry problem, we always start with what we're given. So we start with 16 grams of MgCl2. And we have to multiply to get to moles. And that means we have to use the molar mass. It says 15 on my worksheet. You mean the 4th of July worksheet or the, let's see. I'm looking at this one. Lesson 2 worksheet. Should be this problem down here, 16 grams. No.
I'll put my stuff in.
All right, the 16, is it 16 grams or 15 grams?
It's 15. Even on this one. No.
Oh, this is last class's worksheet. The homework problem from last time.
Yeah, whatever.
Do we all see what I'm talking about? Okay, so it's just Kevin that was confused.
What?
All right.
Bro, I just needed my worksheet.
All right, so we have 16 grams of MgCl2, and we want to find how many grams of NaCl we have. So we have to multiply by the molar mass of MgCl2, which is 95 grams of MgCl2 by 1 mole of MgCl2. And then we look at our chemical equation here. We see that we have 1 mole of MgCl2 for every 2 moles of NaCl. And now we have moles of NaCl, but we want to get to grams of NaCl, so we have to multiply by the molar mass. So we have 1 mole of NaCl is equal to 58 grams of NaCl. So when we plug this all into our calculator, divide by 95 times 2 times 58, we get approximately 19.5 grams of NaCl. Any questions on how I did that? Yes, no? Go ahead and shout them out if we have any questions. All right, another question I wanted to go over is, you might have seen this on the 4th of July worksheet, the week that we weren't together, was on crisscrossing ions. When we have ions like this, Ca plus 2 and S minus 2, after we crisscross them, I might not have made this clear last time, and we get Ca2S2. This is okay, because the atoms are balanced. But whenever we have, you see Ca2S2, you see how they're both divisible by 2? When we can divide them by a common number, we prefer to simplify them. So the final answer is CaS. So we simplify the subscripts when we can. All right, we all good? All right, so that was the homework. We reviewed the homework. Let's move on to today's lesson if there are no questions. So let's take out our packet, which my camera can't focus, but that's okay because I'm going to draw it out anyway. So today we're talking about limiting reagent and combustion analysis. Anybody ever hear of that? We got a couple hands. Do you guys want to take a guess at what it is?
I mean, isn't the limiting agent when you're doing a certain stoichiometric equation where you're giving a certain amount, but there's another amount that's not, or there's like a limiting factor, so you have a total amount, and you have like a total amount of one substance, which limits how much you can have of another.
Exactly. Yep. And we're going to get to that. That's perfect. All right. So what happens is I want us to start by doing the first problem on that worksheet. So it says we have the same reaction, and we start with 15 grams of MgCl2. And I want to see how many grams of NaCl do we have. Do we all see where I'm pointing? Let's do the math real quick. How do we do that? And feel free that when someone gets it, unmute, yell it out, and tell me what you got.
Is it like 18.32-ish?
18.3, let's check. So 15 grams of MgCl2 times the molar mass. You can look up when you're done to get the answer. What is wrong with this camera? So you have 18.3 grams of NaCl. Did we get that okay? All right, so that was easy enough, right? Because we started with 15 grams, and we always start with the thing we're given, and we do the stoichiometry using those coefficients as ratios. However, let's say we have, and I will get a new sheet of paper. Let's say we have another problem. The next example we have, let's say we have 15 grams of MgCl2 and we have 15 grams of NaOH to start. How much NaCl do we get? Notice here we run into a problem. Before, we were given only one starting material, but you notice how in this problem, it gives us two starting materials to start with? So which material do we start with? Which one do we use to do the stoichiometry? So what happens is we introduce a new rule here. The rule is when you have two starting materials, you have to do the math twice, as if last class wasn't bad enough. For these kinds of problems, you have to do the math twice, and you pick the answer that gives the smaller amount.
That's so stupid.
Yeah, I know it's stupid. It's not fun. All right, so which means that this is our first starting material, 15 grams of MgCl2. So let's start. That's our first thing. We're going to do 15 grams of MgCl2, and we have to get it to NaCl times the molar mass. I know I'm blowing through this, but hopefully we got some good practice doing this on the worksheet last week. Now we're in moles of MgCl2. We want to get to moles of NaCl. And now we want to get to grams of NaCl. We get 18.3 grams of NaCl. That was our first material, all right? Now we have to do the second starting material, which is NaOH. So we start with 15 grams of NaOH times 40 grams of NaOH in 1 mole. of NaOH. And we look up here at our formula, and there's 2 moles of NaOH in every 2 moles of NaCl. And then 1 NaCl is equal to 58 grams of NaCl. And that gives us about 21.75 grams of NaCl. So we did the math twice, right? Because we were given 2 starting materials, the first one and the second one. So we did the math twice and we got 2 different answers. The true answer to the problem is always the smaller number, which means that when 15 grams of MgCl2 react with 15 grams of NaOH, you will produce the smaller product. You pick the one that produces less product. And that is called the limiting reagent. So I'll write it down here. MgCl2 produced less. It produced less NaCl. Therefore, it is called the limiting reagent. In other words, it is the thing that runs out first. So I'll put that here, runs out first. All right, we need an analogy here. Here's my analogy. Anybody here into flowers? All right, here's what we have. Let's pretend you have a picky, overly sensitive, extremely emotional, whining girlfriend who only likes flowers and bouquets a certain way. All right, so you see here, extremely emotional, whining. There's the girlfriend right there.
Yeah.
See that? It's 2023, so we don't know what her gender is. I don't know. Maybe he doesn't have a gender. I don't know. Anyway, let's say your girlfriend likes bouquets, and 1 bouquet is equal to 2 roses and 1 tulip. All right, that's just the way she likes them. A bouquet, a set of flowers. However, let's say your dumbass goes to the store and you buy exactly 10 roses. 6, 7, 8, 9, 10. That's 10, right? Someone double check. Let's say you come home with 10 roses and 10 tulips, and you want to try to please your lucky lady. I don't know who. Who knows? So we know that 1 bouquet is 2 roses and 1 tulip. So this is a bouquet. 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 But notice how the roses run out first. Therefore, the roses are the limiting reagent because it limits how much product we can make. You can't make a bouquet with only tulips that are left over. So the thing that runs out first limits how much product you can make. So regardless of what you do here, regardless of how you try to do the reaction, your girlfriend will still cry.
Yo, Justin.
Bad, huh? Yeah?
Aaron Park forgot to write down the work on the other one, so can you pull it up?
Yeah. This one?
Yeah.
Camera still focused?
Yeah.
It keeps jostling up and down. It's Any questions on the limiting reagent, what it is, while he's copying that down? Oh boy, someone put something in the chat.
No, I accidentally raised my hand. I apologize.
Oh, okay. Thank you, Kevin, for your contribution. All right, let me know when you're done.
I'm good.
You're good? All right. So, what's our rule? What was our key takeaway for this first part of the lesson? Because believe it or not, that's the limiting reagent. Oh, I bumped the camera again.
That your boyfriend, I mean girlfriend's real whiny.
Yeah, anybody heard of Ram Gunapar? Oh, no. I can't go.
Yo!
Sorry, I can't go there. All right. So, when we have one starting material...
Karen will be hearing about this.
Oh, you know, she just accepted my Instagram follow request.
Yeah,
All
she
right.
accidentally
So
liked my comment.
if we have one starting
Riz.
material, we just do the simple stoichiometry that we've been doing all these weeks. However, if we have two starting materials, like that problem I just gave you guys, what you do is you do the math twice, do the math 2 times, and pick the smaller product. All right, does that make sense? All right, any questions? All right, let's go on to our next topic. Oh, we're flowing along in this class, right? This class is not as intensive as last class. I know last class we covered a lot of material. How is the material from last class? Is it getting a little easier the more we practice? Sorry that I posted so many problems on that worksheet. Did anybody catch that the last page was literally the same problem that I did in class? And I just wanted to make you guys do the problem again to make sure you could get it right.
I didn't do the worksheet, so.
Oh, Kevin, that explains why we're lost.
I'm not lost. Who said that?
All right, now we're going to talk about combustion analysis. Right down here on our little worksheet. Now, what exactly is combustion analysis? Now, we're going to look at the general combustion formula, which means we start with a hydrocarbon, which is something with carbon and hydrogen in it. Sometimes there's an oxygen in it too. Sometimes there isn't. And we burn it. Feel the burn.
Your shit went blurry.
Oh, God. Right when I said burn too.
It's not blurry anymore.
So we take a hydrocarbon and we burn it. All right, Kevin's giving me my camera guy now. Make sure nothing goes blurry. And when we burn it, we get CO2 and H2O. Does that make sense? Now, here's the thing. Sometimes chemists are not the smartest people. And we burn stuff before we know what it is. What happens is, let's say we didn't know what the starting material was. Let's say it was C and H. We know there's carbon. We know there's hydrogen in it, but we don't know what exactly. We don't know what the ratio between carbon and hydrogen is. We don't know the subscripts. So, besides standing there and crying because you just burned your only material, we can actually figure out what the starting material is by measuring the amount of water and the amount of carbon that comes out the other end after we burn it. So an analogy of this is like, let's say a candy wrapper. Let's say you go on the street, you find a candy wrapper, somebody littered it on the ground. You don't know what the candy was because it's just a sheet of paper. So the candy wrapper is kind of like our carbon dioxide and water. It came out the other end. But if we read the stuff on the label of the candy wrapper, we can figure out what the starting candy was.
Out
We're
the
working
asshole.
backwards. The what?
Out the asshole like Ram Gunapur.
That's a conversation for after class. All right, so do we kind of get this, how combustion analysis works? So we're pretty much playing detective. We're using the amount of water and the amount of carbon that came out the other end, and we're using it to find how much, what the starting material was. All right. So let's do a problem, and I will walk you guys through the steps. Oh, maybe that's why this thing keeps moving. So let's say we have 2.903.
It's blurry.
Oh boy.
That's better.
Why can't this be like our eyes? Why can't they just
'Cause you're
naturally?
Asian.
No, you know that the eyes have a ciliary muscle that controls the lens. The lens is the part of the eye that converges light as it goes through the vitreous humor to the retina.
Bro,
So,
just drop more money on a better camera. It's not that deep.
all right, that's coming out of your pocket, Ethan.
I don't got money, bro.
So let's say we start with 2.9 grams of this hydrocarbon. We don't know what the ratios are, but we do know we start with 2.9 grams. And it produced 5.801 grams of CO2 and
Get
2.37
blurry.
grams of H2O. All right. We good with that? All right. So we know the grams, the amount of CO2 and the amount of H2O we ended with. Now we have to work backwards to find out what this was. So step one. We always find the moles of carbon first. And you always want to start by finding the moles of each atom, carbon and hydrogen. So find moles of carbon. So we know that we have 5.801 grams of CO2, right? And we want to find the grams of carbon. So this is just like our grand auto theft problem we had a couple of weeks ago. What we do is we need to get this to moles first. So how do I get it to moles? Blurry again. I have to multiply or divide by the molar mass, right? So it's 44 grams of CO2 in 1 mole of CO2. And I know that for every 1 mole of CO2, there's 1 mole of carbon, right? So I multiply everything out, I plug it into my calculator, and I get about 0.132 moles of carbon. Now, let's look at our combustion formula. We start with carbon, and we end with CO2. But CO2 is the only product that has carbon in it. So any carbon that we end with has to have come from this, right? From the starting hydrocarbon, because matter cannot be created or destroyed. All right, so therefore, since we know that we have 0.132 moles of carbon here, we also have 0.132 moles of carbon here from the starting material. All right. Any questions on how I deduce that? All right, let me go to step 2 now. Step 2 is find moles of hydrogen. So to do that, we're going to use water. We have 2.375 grams of H2O. And we have to get it to moles, so we multiply or divide by the molar mass. There's 18 grams of H2O and 1 mole of H2O. Now we have to get to hydrogen. For every 1 mole of H2O we have 2 moles of hydrogen. Does that make sense? Because every H2O has 2 hydrogens in it. We plug this into our calculator, and that gives us 0.264 moles of hydrogen. And once again, since H2O is the only thing at the end that has hydrogen in it, the amount of hydrogen we end with equals the amount we started with. Are we good with that so far? All right. Now, step 3. Find the amount of oxygen. Okay. This is not going to be fun. I want everybody, all right, take a deep breath. All right, so take a deep breath before we start this because this
Yeah,
is gonna
please.
get real. Oh, where have we heard that before? Someone doing drugs in the back of the
Yo.
class? Not this again. All right, so
Aaron, turn your camera on.
notice how
My bad.
oxygen is in both carbon dioxide and water. However, the hydrocarbon at the beginning doesn't always have oxygen. So we can't really use the amount of CO2 and the H2O that we end with to find how much oxygen we had at the start. Because the oxygen could have come from the starting molecule, like it did here, or it could have just come from the air. So we have a special series of steps that we use to find oxygen. Oh boy. All right, this is not going to be good. So we know we started the very beginning with 2.903 grams of CHO, and we don't know the subscripts. Do you all agree with that? So here's the thing. We already found how many moles of carbon we have, right? We have 0.132 moles of carbon. And we already found how many moles of hydrogen we have because we found that we have 0.264 moles of hydrogen, right? Therefore, if we convert the amount of carbon and hydrogen to grams, we can subtract the amount of grams from the starting material, and whatever is left has to be oxygen. Does that make sense? Let's say, like, just for analogy, let's say we have CHO. Let's say the whole thing is like 10 grams, and we already know the carbon is 2 grams, and we know the hydrogen is 6 grams. Do you agree that to find the oxygen, since we know that the whole thing is 10 grams, and we know the carbon is 2 grams, the hydrogen is 6 grams, we can just subtract these two from the starting 10 grams to get the oxygen? So the oxygen would just be 10 grams, which is the total, minus 2 minus 6. All right, so we're going to do exactly that. Camera still focused? All right, so I might need another sheet of paper for this too. First, we have to take the amount of carbon and hydrogen and turn it to grams. So we have 0.132 moles of carbon, right? And we want to turn it to grams. So we have to multiply by the molar mass of carbon. Anyone want to help me set up the ratio here? Not all at once.
Wouldn't it be 12.01 over 1 mole?
12.01 divided by,
Or 12.01 grams per mole?
yep, exactly. Oh, we're fancy. We're using decimals today. I'm going to abbreviate it as 12 for the simplicity of my tiny brain. All right. So now when we put that in a calculator, we get 1.584 grams of carbon. All right. And let me focus the camera.
It's blurry.
Thank you, Ethan. All right. Now we found the grams of carbon. Now we have to find the grams of hydrogen. So we have 0.264 moles of hydrogen times 1 mole of hydrogen is 1 gram of hydrogen. And that gives us 0.264 grams of hydrogen. Now, this is where the secret sauce comes in. We have carbon in grams. We have hydrogen in grams. And we started with 2.903 grams of the whole ass thing. We don't know these subscripts. So now, we start with the total. We subtract the grams of hydrogen, the grams of carbon. We subtract the grams of hydrogen. And we should be left with the grams of oxygen, which is, we put it into the calculator, 264, and that gives us about 1.055 grams of oxygen. Does anybody need me to repeat anything? Do we understand how I got that?
Yes.
Yes?
Yes.
All right. Nobody's crying yet, which is good. Somebody cried in AP Chem. Well, a couple people cried. And it was during the titration lesson, which is the hardest part of chemistry, which is coming up during lesson 8. So you guys will have me for that part of the
I'll
lesson.
just laugh at them.
Nah, I don't. If it was a girl that cried, if it was a dude that cried, maybe she would have. Shit. Hey, I know a dude that cried in AP Calculus.
That's
Okay.
calculus, man.
Oh, and anyway, yeah. If you guys noticed, this class is getting more math intensive, right? There's a lot of math involved. There's more, just so you know, there's more math in my section of this class than in Gautam's section, the other instructor. So if at any point you're like, oh my God, this class is so hard, I can't handle this, keep in mind it gets easier as soon as the other instructor takes over. All right, so anyway, we have grams of oxygen, right? But now we want moles of oxygen because we have to convert everything into moles first. So we have 1.05 grams of oxygen. We have to convert it to moles. So we multiply or divide by the molar mass. 16 grams of oxygen in 1 mole of oxygen. And that gives us 0.0659 moles of oxygen. Now, I'm going to rewrite everything on this page so that it makes it more clear. All right, so we found that we have 0.132 moles of carbon, 0.264 moles of hydrogen, and we found that we have 0.0659 moles of oxygen. That's where we got so far. The oxygen was the hardest part to find. Some problems don't have oxygen, and if they don't have oxygen, you can just skip it. So we're here. We have the moles. Now we have to find what the subscripts were on these. So the last step is once you get everything into moles, the last step, which is, what step are we on? 4? To divide everything by the smallest thing. So,
Justin, I think you should check on Aaron. He was bobbing up and down in his camera.
oh, someone having a seizure? Oh God.
No.
You know how bad? Yeah. Fix the chroma.
Kevin, you're crying in your CP geometry class.
It's actually honors, and I wasn't crying.
You know how bad that sounds in my reputation that my class made someone have a seizure? Okay, so divide everything by the smallest thing. What's the smallest thing here?
Rom's pit.
This is a measuring contest here. All right, what's the smallest thing? I knew he would say that.
Oxygen.
Oxygen, right? So we're going to divide everything by oxygen. So we have 0.132 carbon, moles of carbon, divided by 0.0659 oxygen. It's moles, but I'm not going to write it. And then we have 0.264 moles of hydrogen divided by 0.0659 oxygen. If I put that into the calculator, I get 2 for this. That means there's 2 times as much carbon as oxygen. Do we get how I did that? Like math? When I divide this on this side, I get about 4. which means there's 4 times as much hydrogen as oxygen. So to put it all together, I have CHO. The smallest thing was oxygen. So I'm going to say the subscript is 1. We have 2 times as many carbons as oxygen. So I'm going to name the carbon as 2. And we have 4 times as much hydrogen as oxygen. So I'm going to name that as 4. And that is our starting material.
You're so smart.
Any questions at all? Because that is all I have for lecture today. Surprise, right? We actually finished early. Raise the hand. Yeah, you don't have to raise a hand. You can go ahead and shout it out.
I just had a quick question. This might I don't know if this was covered in a previous lesson, but how do the sig figs work here? Like because if we I'm not sure if this is what I'm saying is fully correct, but if we approximated the molar mass of carbon to 12, and here in carbon in the previous I forgot which it was, but we approximated to nearest 10,000, but here we have
significant digits. That's what you're talking about.
Yeah.
No, did you take chemistry before, or do you study it on your free on the side?
In Science Olympiad, I did a few chemistry.
Science Olympiad. All right. Significant digits. For my class this summer, don't even worry about them. Don't even worry about it. I didn't even cover it in the past 2 lessons because it's so meticulous. It's so so many rules. You guys can learn it when you take AP chemistry, but it's not the worst thing to learn for most people, so I just skip it. I would much rather focus on the chemistry, the math, rather than the little details of significant digits. Okay. But yes, you are correct. They will take points off on the AP exam if you round to the wrong decimal place.
Got it. Thank you.
Actually, I didn't understand significant digits until I got to college. Do you believe that?
I kind of still don't understand. I mean, I understand the rules, just not the why. I mean,
not why. You can stay after class, and I can answer that. I have a good explanation as to why.
Okay.
All right. Yeah, good question though. Anybody else? Pretend you didn't hear that. Any other questions? Let me get a quick look at everyone. Nobody's crying yet? Kevin's then. I haven't cried in 7 years. All right.
Bitch.
Cap.
Hey, look who's crying emoji on the screen. All right, so let's go to our worksheet now. All right, so work through the problems. You guys can unmute and talk to each other if you want to bounce ideas off each other, or you can ask me if you have any questions. Actually, Jeremy, do you want me to explain the sig fig thing now while we're here, so I don't keep you too long? And then everyone else, if you don't want to listen, you can just turn off your microphone.
Yeah, sure. That'd be great. Thank you.
All right. So here, let me get a fresh sheet of paper. So when it comes to significant digits, let's say we have 2.15 plus 3.1. So the rule with adding is you match the lowest decimal place, right? Like you match the lowest number of decimals after the decimal point. So when you add it, (2.15 plus 3.1), you get 5.25. But since this one had 1 number after the decimal and this one had 2 numbers, you only keep this digit, right? You only keep the first 2 digits. So the question is, why do we go by the least number after the decimal? Why don't we go by the most numbers after the decimal? This is what confused me for a long time, because the thing with sig figs is that we're going for accuracy and precision. Shouldn't having 2 decimal points after 2 numbers after the decimal be more precise than having only 1? What's that?
No, I was about to. Isn't it because it's like the measuring of the like machine that you're using? If you're like, oh,
Yep, go
like
on. Go ahead.
if you're using a less accurate machine, you make sure that your results are more akin to the assuming that each machine is as accurate as the least accurate machine to make sure that there's some not evenness, but there's not a misreport like in how accurate your machines or statistical tools are.
That's exactly how it is. In this number right here, 2.15, we know this digit for sure. We know this digit for sure. But then in this one, we only know the first digit for sure. We don't know what this last digit is. We're only assuming that it's a 0 for when we add it. But then when we get the result, we get 5.25. We know this digit for sure because we knew the 2 and we knew the 3. We know this digit for sure because we were sure of this value, the 10th place, and this 10th place. But for this value right here, the very last digit, since we knew this place value in only one of the numbers and we didn't know it in the other, we were only assuming the value. So really, this last digit came just by chance. We ended with this digit because of the way we added the numbers, not because of how sure we were, how accurate the numbers are. So since we only know the first these 2 digits for sure, and we're not sure of this one, we're only allowed to keep these 2 digits because that's the ones that we know we measure for sure.
The call's about to end.
Yeah, boy. Does that kind of make sense?
Yep, that makes sense. Thank you.
Because really, the last digit only came up by chance.
Outside the secondary question,
Yeah.
for the context of AP Chem, like I know different instruments, like different beakers and such, have different ranges in which like their like the scientific like the measurement accuracy falls between. Do we need to know that for the AP exam, or is that something that just does that like that's not like outside the scope of the AP exam?
I'll know what to use when you measure what.
Like if you like certain like instruments, like standard instruments, like a certain beaker have different ranges. Like we know that the value is between this and this because you lose a certain amount of accuracy with less precise instruments. Do we need like will any question tell us like if this instrument is has like a given precision between this and this value, so we know it's between these 2 values? Will we be like asked to work with that, or is that just outside the scope of the AP?
I don't recall having that on any of Powell's AP exams or the AP exam, but they might give you a problem. It's called error analysis, where it's like, let's say you spilled a little bit of liquid by accident in the reaction. Or let's say you misread the burette by this much. How will that affect the results? Will you get a larger number than you should, or will you get a smaller number than you should? They might ask that, but I don't think they'll ask for measuring it.
You probably know more than Justin anyway, so.
Hey, Ethan, you want to teach the class? He's probably...
Well, I'm not saying that I know more than you. I'm saying that Jeremy probably does.
Here's the thing. I struggled when I took AP Chem. I really struggled when I took this class.
You shouldn't be saying that.
And
class, bro.
By the time I finished AP Chem, I think I only walked away understanding maybe half the material or 2/3 maybe. I just couldn't wrap my head around chemistry. So I went on saying, oh, chemistry sucks. So then I went to college. I took the class again so I could learn it again. And I got a 99 and a 100, average the whole year. So I ended up asking myself, why was chemistry so bad the first time? And the answer is time. It takes time and preparation for the information to sink in. So then that's what brought me to this class. Just to expose yourself to material before going in. Because I went into AP Chemistry knowing nothing. I didn't know what a mole was or what a molar mass was or anything like that because we didn't take chemistry before. So that's my goal here, just so you guys don't get shocked when you go in next year. Many of you guys are probably smarter than me anyway.
Did you not have summer work?
The summer work back then didn't even cover moles, to be honest. Wait, what's the summer work now?
Justin's not that smart.
Wait, Wait, is the summer work still just the first 2 chapters?
Yeah, it glosses over like dimensional analysis. I don't know about the second chapter though.
Do they do any like titration or solubility or like
No.
KS equilibrium?
No, doesn't. At least the first chapter doesn't even like touch on what, like it just touches on dimensional analysis, and I believe it also might talk, like part of it might talk about significant figures, but I'm not sure about the second chapter.
Oh, that's the use most.
Yeah,
of
the second chapter is mainly like just talking about the basic measurements, like moles and all that.
Oh, you see, I didn't really like pay too much attention to summer work, and I don't know. Chemistry is. Yeah, you guys want to know a secret? Actually, I actually really hate science. You guys know that?
No way.
No way.
I hate science. I hate biology. I hate chemistry. I hated earth science because I thought it was dumb. I really only like math, to be honest. But just because you hate something doesn't mean you can't do well in it. That's what I'm here to prove.
I think you're just stupid.
Look at the transcript. Yeah, earth science is hard. Yeah, exactly. Earth science. Yeah, polar bears can drown.
Yo,
Bro,
that's
get this girl.
iceberg.
Get this girl
Yo,
Hui
get
out of here,
Hui
bro.
out of here, bro.
Get Hui out of here.
Yeah, have no purpose.
Yo, Hui have no purpose.
Yeah.
Oh yeah, my algebra kids are still here. Say hi, algebra kids.
Kick them out.
Kick them out.
Let's not pick on the algebra kids. They're gonna be here someday taking the class.
Is Hui a guy or a girl?
Aaron, that's not a good question to ask nowadays.
Oh yeah, we
My
got
bad.
the professor got pissed in college once because we said pregnant women instead of pregnant females. He said
What's the difference?
this was in general
What?
anatomy. This was in general anatomy physiology, where the professor said we will not use pregnant women in this class. We will use pregnant females because women is not inclusive of like males that identify as females and like like females that change to males and they like get fucked and then like pregnant and then I don't know. It's
Yo, that's,
Bro,
the,
incomparable.
that's the point of the pregnant male emoji, bro.
Justin, just drop that class.
I got an A in that class. I can't drop it now. I hated that class
I don't know
though.
how you get A's in classes, Justin.
Stupid.
So do you guys want to know about what list Justin was talking about earlier?
Ethan, that's irrelevant
Yes.
at this point. You can private message Aaron. I see you have the phone. Does he have his phone number?
Nah, Kevin already told me all about your list.
It's
Yeah,
the Santa
Aaron, do you
Claus
want to
list.
elaborate about the list?
So the it's called the R word list.
Oh boy.
I'm not gonna get into
confirming
much further
that. I'm not
information.
confirming that.
Justin, can you elaborate?
There are allegations against me that I do. I feel like who's that guy? Brett Kavanaugh. Yeah.
Do you plan
Brett
on
Kavanaugh.
putting some of the Algebra 1 kids' names on this list?
Oh my god.
All right, the meeting's about to end. I will send an extension link in case you guys want to come and work through the problems and see the answers. We'll go until it kicks me out, and I'll send an extension link. But if you guys feel like you have it, you guys are free to go on. Maybe I'll put the answers on.
Justin, am I on the list?
Yes,
What?
you've been on the list.
Justin, I'm your brother though.
So,
Yeah, that's crazy.
why is the camera focused now but not before? I gotta fix this thing.
All right, good night, Justin.
Good night. Hopefully this class wasn't too bad. Next class, we're going to talk about fluids.
Semen.
Oh, man. Take Sadvik's class if you want to talk about that. Or Jeremy's class. Yeah, he's still
Wait,
here.
do I still gotta record this part or nah?
Maybe when I go over the answers or if you have the answers. You could actually, that's lecture. You could, yeah, these are the answers. Take a look at them when you finish your work.
So can I stop the recording?
Yeah, you can stop it.
Meh. Hi, meh.
You're unmuted, Kevin.
I know. Huh? Nah. Alright, whoever's watching this, I'm gonna see you.